Okay, this is exam 2 for Physics 201, fall 2015. Let's see. Consider these vectors. What is A minus B? Well, there's the vector A. It's in this direction. The vector minus B looks like that, so I'm going to draw it like that. So the vector C will look like this. So that's option A. Which of these are vector quantities? Let's see, not mass, not distance, velocity, and acceleration. So A is the right answer. Vector A lies in the xy plane. At what angle from the x-axis will the vector A have negative x and y components? All right, negative x and y components would be over here. So I'm looking for an angle that'll put me in that third quadrant. So remember, this is 180, this is 270. So somewhere between 180 and 270, that's going to be 210. Vector A has a magnitude of 12 meters. Vector B has a magnitude of 25 meters. Which of these is a possible solution for the sum of A plus B? Remember, I have maximums. I have 25 meters in this direction and then 12. So that would give me a maximum of 37. That's my maximum. The minimum that I can get is if 25 is in this direction and 12 is in this direction. So that would be 13, 25 minus 12. So it's somewhere between 13 and 37. And it looks like A is the only one that falls in that range. The vector has a magnitude of 12 and 20 degrees above the x-axis. What is the x component of that vector? Well, the x component is just going to be 12 cosine of 20. And that's going to be 11 meters. So C is the right answer. Projectile is fired at 25 degrees above the horizontal. At the highest point of its trajectory, its speed is 100 meters per second. So at this point, its speed is 100 meters per second. If air resistance is ignored, the initial velocity had a horizontal component of what? Well, 100 meters per second is here. Remember, the horizontal component does not change. So the initial velocity then in the x direction was 100 meters per second. Two shells are fired simultaneously from the same battleship at two targets. The shells follow the trajectory shown here. Which target will be hit first? The one that takes the least time is the one that goes to the least height. So target 1 is hit first. A pilot drops a package of food and water supplies from a plane flying horizontally at constant speed. When the package reaches the ground, the plane's horizontal position is directly above the package. So remember, if I have a plane, it's traveling along like this. It drops a package, which travels along like this. At every point, the plane is over the package as the package falls. Stone is thrown horizontally and follows the path shown. The direction of the velocity of the stone at point Y is shown by which of the vectors? All right, well, at point X, it has a velocity vector that looks like that. All right, at point Y, because here the Y component is 0. At point Y, the Y component is in that direction, and the X component is in that direction. So the net velocity vector is in that direction. So which one is that? That's going to be D is the right answer. An object is moving at constant velocity. Which statement is always true? Okay, not necessarily no forces. There's only one force, not necessarily that. You could have that actually. The net force on the object is 0. B, if you have an object that's moving at constant velocity in this direction, say it's on a frictionless surface, you would still have the force weight. So you could have B, but not necessarily. And there must be more than one force acting on the object. That's not true either. If it's moving at constant velocity, the acceleration is 0. If the acceleration is 0, the net force is also 0 by Newton's second law. The fact that a dime pulls upward on the Earth with a force equal to the weight of the dime is third law. Two objects A and B experience the same net force. Object A accelerates at twice the rate of B. Therefore, well, I know F equals ma. F is the same for both. I have twice the acceleration for object A. I have twice the acceleration. It must have half the mass. So mass of A is half that of mass of B. Consider this figure. Which of the following equations is correct? All right, let's see here. FW cosine 60 minus FS. All right, let's just sort of sketch in some. I have FS here. I have FN here. And I'm going to go ahead and put in my weight components. This is FW sine of 60. and this is FW cosine of 60. So FW cosine 60 minus FS equals 0. That's true. FW minus FN, that's not true. See, FW and FN aren't anywhere, and there's not true. FW cosine 60 equals MAX, doesn't have the frictional force. FW sine 60 equals FN. Okay, that one is true, so A is the correct answer. Consider a block that is at rest on an inclined plane. The only forces acting on the block are frictional, normal, and gravitational forces. Which of these statements best describe the normal force? I have an inclined plane, the normal force points up. It is equal to the component of the weight in the y direction. All right, so that means it's less than the total weight, so B is the right answer for 14. Okay, so let's look at these free response. Nickel soccer player kicks a ball at an initial speed of 20 meters per second, which happens to be 50 miles an hour at some angle. The ball travels a certain distance at that time. What is the maximum height of the ball? This is our scenario. I have an initial velocity equal to 20 meters per second. I don't know what this angle theta is, but I do know that at this point, the time equals 2.58 seconds. Then I can also say that at this point, the time equals half that, 2.58 divided by 2. I'll show you why we're going to use this in a second, but that's equal to 1.29 seconds. Okay, I also know that x equals 39.5 meters, and that's all. Now, I want to know what is the maximum height of the ball. I want to know what is the y position at this point. That's why I need to know this time in order to find the y position of the ball, the maximum height of the ball. So I have to do a couple things, though, because I don't know the angle theta. I need to find out that. But I do know the x displacement, and I know that that's equal to v naught x times t. So that's 39.5 meters equals v naught, which is 20 meters per second. It's actually 20.0 meters per second, times the cosine of theta, times my time, which is 2.58 seconds. I use 2.58 seconds because I'm looking at the position over here all the way at the end. And then I can solve this for theta. And take the inverse cosine of both sides, and I find that theta is equal to 40 degrees. All right, this was one part of the problem. I considered this to be worth about 6 points. All right, now on the next part, you had to find the y displacement. The y displacement then is just v naught y times t plus 1/2 a t squared. Recognizing that we're using t top here, so we're using that 1.29 now, not 2.58 seconds, but 1.29 seconds. And so this is going to be 20 meters per second times the sine of 40, now that we have that, times 1.29 plus 1/2 of negative 10 meters per second squared times 1.29 squared. And that gives me 16.6 minus 8.32. That's 8.26 meters. That's my y position. That's my final answer. Consider this to be worth 7 points. And then it was also important that you get the right time here, so this was another 2 points. Okay, here I have an object with a mass of 3.4 kilograms. It has two forces acting on it. First, I want you to just draw a free body diagram. So here's my coordinate system, and now I'm going to draw that free body diagram. As I just want to draw the forces. I have 22 newtons, which is acting downward. 22 newtons acting downward. And then that's the force number 2. I also have this force number 1, which is 12 newtons at 25 degrees above the x-axis. So it would be here. But I'm going to draw the resolved vectors. That's going to be 12 sine of 25, 12 cosine of 25. Okay, now I want to know what is the acceleration of the object. In order to do this, I have to, this is part A, in order to do that, I have to find what is the net force. So I can further say that the force in the x direction is going to be negative 22 plus 12 sine of 25. That's going to be minus 17 newtons. And then Fy, excuse me, this is Fy, I'm sorry. Fx is 11, 10.9 or 11 newtons. Just adding up those vectors, and then I do Pythagorean theorem, 17 squared plus 11 squared, that's equal to 20 newtons. And I also want to know the direction of this. Let's see, did I list this? Yeah, I want to know the magnitude and the direction here. You should have had this on your test. So that's the magnitude. Now I also want to know the direction. Theta is the inverse tan of the y component, which was 17 over 11. That's 57 degrees. And based on my components here, this is below the positive x-axis, because my net vector here of these two vectors is going to be sort of right here. Right, that is the force. I actually want to know what is the acceleration. So the magnitude of the acceleration is just going to be F over m. That's 20 newtons over the mass, which was 3.4 kilograms. .9 meters per second squared. So that was the actual answer, and that's the magnitude and the direction. And then I want to know, a third force brings the object into static equilibrium. What must the magnitude and direction of that force be? Well, you've already done all the heavy lifting here. I know that the magnitude of that force has to be 20 newtons, because it has to be opposite to the sum of the forces, and it has to be 57 degrees above the negative x-axis. Let me draw a figure here. All right, so the other object was here. That was our original force. The force that causes it to give static equilibrium will be in that direction. 57 degrees, 20 newtons. 20 newtons here, 57 degrees. Okay, let's see. The point distribution there. This was 4 points. This was 7 points. And this was another 4 points. Parts. Okay, so now problem number 17. I have, it's a tough problem. There's a lot that went into this, a lot goes into this. So I have two blocks. One is a smaller mass up here, and I have another one that's a bigger mass down here, the 2 kilogram. And then notice also that they have different coefficients of kinetic friction. So these are made up of different materials, so they stick differently to the surface. First thing I want to do is just draw the free body diagrams. I'll just sort of sketch in the vectors right here. So here I have FW1. By the way, I know that's equal to 10 newtons because it's 1 kilogram, 2 sig figs on that. And then I have FN1. And I have tension, FT. And I have my kinetic friction 1, I'll call it FK1. And then down here, I have similarly FN2. I have FW2, which I know is 20 newtons. It's bigger. I have FT, which is going to be the same as what we had because I have this rod connecting them, and it transfers that force in the same way. And then I also have FK2. Now, I want you to draw the free body diagrams with the resolve vectors here. So, FN1. You didn't have to do that first part, but I did want you to do this, and I think it makes the problem a little easier if you write this all out. FW1 sine of 60. Notice I took 90 minus this angle. And then this is FW1 cosine 60. I can go ahead and put in some values here. Like I know that FW1 is 10 newtons, so this is equal to 5 newtons. 10 cosine 60, and this is equal to 8.66 newtons. I'm going to keep 3 sig figs just until the end. All right. Now I can, let's see, I'm missing one. I'm missing the tension force, Ft. Now in the next one, I have Fn2. I have Fw2 sine of 60. Fw2 cosine of 60. And then over here I have Fk2 and Ft. Ft and Fk2. Okay, now I want to know what is the frictional force on block M1 and block M2. For these, I counted these as sort of 8 points combined. For this one, I counted this as 7 points to get the free body diagrams correct. What is the frictional forces? So in order to know the frictional forces, so this is for B and C actually, but Fk is equal to mu k times the normal force. So I just need to know what is Fn1 and what is Fn2. So Fn1 is equal to, if I look at this, I can say, you know, the sum of the forces in the y direction, Fn1 minus Fw1 sine of 60, that's equal to 0, and so Fn1 is equal to Fw1 sine of 60. You didn't have to go through all these steps, but that's how you get it. So Fn1 then is just 8.66 newtons. And then Fk1 will be 0.2 times 8.66. And that's equal to 1.73 newtons. So that's my Fk1. Now for C, I do the similar thing for Fk2. I need to find Fn2. And in the same way that I found it there, I'm just going to be equal to my Fw2 sine 60, which is 17.3 newtons. That's going to be 20 times sine of 60. So it's going to equal 0.1 times, well, excuse me, I'm sorry, this is 17.3 newtons. And then Fk2 is 0.1 times 17.3 newtons. So that's 1.73 newtons. So even though they have different mu's, because they have different normal forces, they have the same frictional force. Okay, so that was, now I want to know D, what is the tension in the rod and what is the acceleration of the two-block system. In order to do this, we're going to need to write our equations for the forces in the x direction. So I'll go ahead and do that here. I'll do this one first. I'll go ahead and use the value here. 5 plus Ft minus Fk1, that was minus 1.73, which we just found, is equal to the mass, that was 1 kilogram, times the acceleration. So that's some of the forces in the x direction for block number 1. Now the sum of the forces in the x direction for block number 2. Let's go ahead and put in some numbers here. This Fw2 cosine 60 is, what was Fw2? 20. So this is going to be 10 newtons. So I'm going to have 10 minus Ft minus 1.73 equals to 2a. So these are my two equations. I'll set them up in a slightly different way. So I'm just going to take these two and I'll rewrite them a little bit. I have Ft minus a equals negative 3.27. What I've done there is I've just solved this for Ft minus a. I'm doing this to set it up for the matrix mode, but I'm going to solve it for that Gaussian elimination, but I'm going to solve it by substitution first. And then the next one, solving this equation, I get Ft plus 2a equals 8.27. And you solve them however you like here. I solved this equation for a. So I get a equals Ft plus 3.27. Then I take this and I plug it in here for a. Ft plus 2 equals 8.27. Then I solve this for ft. I'm not going to bore you with the algebra, but it's 3ft equals, I'm sorry, I know it's not boring actually, equals 1.73. And so ft is equal to 0.58 newtons. So that is my tension in the rod, and that's the first part of the problem. And then if I want to find my acceleration, well, I already have an expression for my acceleration. I just plug that in up here, 0.58 plus 3.27, and I get 3.85 newtons. And that is, or excuse me, meters per second squared. That is my acceleration, and that's the answer. But let me go ahead and do it by Gaussian elimination. So my equations looked like this. I had ft minus a equals negative 3.27, and then I had ft plus 2a equals 8.27. So this is an augmented matrix. I'm going to do first, I'll replace row 2 with row 2 minus row 1. And so that'll be 1, negative 3.27. That's the same. I do 1 minus 1, that's 0. 2 minus negative 1, that'll be 3. And then 11.54 minus negative 3.27, or excuse me, 8.27 minus this value, which is going to be 11.54. I'll replace row 2 with divided by 3. Get 1, negative 1. Starting to see some of my solution come up. Here I have the acceleration there, which is 3.85. But I still need to get that first row in reduced form. So I'm going to replace row 1 with row 1 plus row 2. So that'll be 1 plus 0 is 1, negative 1 plus 1 is 0, and negative 3.27 plus 3.85 is 0.58. And it's in fully reduced form of the identity matrix, augmented identity matrix. So these are my answers. This is ft and this is a. We did that by substitution, but you can do it this way. It took about the same amount of time, I think, but you know, knowing sort of how to do it is the hard part. Okay, consider this block. It is 5 kilograms on a horizontal surface. The coefficient of kinetic friction is 0.1, static friction is 0.2. Draw a three-body diagram with all resolved vectors. Well, I have the weight, Fw. I have the normal force, Fn. I have the y component of F. That's going to be F sine of 30. And then I have the x component, F cosine of 30. So that's all the vectors. What is the normal force acting on it? Well, I can do the sum of the forces in the y direction. Equals Fn minus Fw minus F sine of 30. It's not moving in the y direction, so that acceleration is 0. So Fn is equal to Fw plus F sine of 30. Fw, let's see, this is a 5 kilogram block, so it's 50 newtons, plus F, which is 12 times the sine of 30. 50 plus 12 times the sine of 30. Oh, it's 56. So that's my normal force. My normal force is bigger than the weight because it has that extra force that's pulling down. And now, so that's B. Now C, does the object move? Yes or no? Okay, what's relevant here is, actually something I didn't draw here, I'm sorry, is that I need to also have my frictional force here. I need to know, does this force exceed the static frictional force? If it does exceed the maximum static frictional force, then it will be moving. If not, then it will not be moving. So let's just calculate what that static frictional force is. Fs is equal to mu s times the normal force. Mu s was given 0.2. So 56 times 0.2 is 11.2 newtons. Now, does the other force, F cosine 30, does that exceed that? So let's see, that's 12 times cosine of 30. And that's equal to 10.4. So since 10.4 is less than 11.2, it is not exceeding the static friction, so it does not move. So the answer is no. And then imagine the surface is frictionless. What is the acceleration of the block? So here, if the surface is frictionless, the acceleration of the block is just F. I do the sum of the forces in the x direction. It's just going to be F cosine of 30 equals to ma. So A will equal F cosine 30 over the mass. That's 12 cosine 30 divided by the mass, which was 5. 10.4 over 5. It's 2.1 meters per second squared. Let's see, I don't remember how, point distribution wise here, I did 3 points for your free body diagram, 4 points for part B, 4 points for part C, and 4 points for part D. Here's the multiple choice answers again.